So we ask a series of questions to reduce the number of possibilities. We know so many different ways and so many different formulas, but which one is likely the one that applies here? So we ask questions like, what type of a problem is it? How many ways to solve this type? Which one looks most feasible? And then which one looks the easiest? Okay. So you notice that this is diffusion inside the compost pile. So this is diffusion inside the compost pile. And so the problem, our domain, is the compost pile. And there is only diffusion in it. There is no convection or flow. So then it must be a diffusion problem only, without any flow. And it also asks for moisture at a certain time. So then it must be an unsteady problem. Okay. Now by now you are familiar with this chart that shows all the steady and unsteady solution possibilities. So in this case, we already said that it's an unsteady state problem. Now, unsteady state problems can be solved in a number of ways, as we have done. One is the lumped, and one is a series by actually using the expression, or series by Heisler chart, which is kind of the same, except that Heisler chart doesn't do very early time. And then semi-infinite is an early time solution or a very thick material solution. And if none of these solutions are appropriate, we can always start from scratch. So those are the 5 different ways of doing things, but we have to now reduce from this list. So let's look at one at a time. So we cross out lumped. Lumped is probably not a possibility. We can check this. We can actually check using the mass transfer coefficient and the dimension and so on. But lumped is very unlikely to be the case. Because to be lumped, the Biot number has to be less than 0.1. You can check this. This is not lumped. Then the next thing is, it is not semi-infinite. It is not semi-infinite simply because we are asked to calculate moisture at the furthest point in the domain, which is the wettest point. So if the moisture is changing even at the furthest location, then every place moisture is changing. So it is not a very thick domain. So in other words, it's not semi-infinite. Now, of the series solution, we have 2 choices. We have expression. We can always start from the expression, but we have to do quite a bit of calculation. But if I can get away with the one-term solution, one term of the series solution from the expression, then we could just simply use Heisler chart. Note that we have been asked to calculate the time. So a priori, before doing the problem, we really don't know if the Heisler chart will work, because if that time happens to be very early, then Heisler chart will not work. But let's start from there. Let's try to use the Heisler chart because it is a unsteady diffusion problem. Let me go over. So it's an unsteady diffusion problem where none of these other solutions work. So we can check, Heisler chart, and it should probably work.